can introduce you while they're organizing. Se quiser, viu? Eu gostei, os meninos já estão falando inglês. Ok.
So this...
Posso começar? Boa tarde a todos, é um prazer estar aqui no nosso 7º encontro do Fórum do DESS de 2024. Queria agradecer a presença da dona Lúcia, né, que é nosso pilar do programa de pós-graduação em Engenharia Civil. Nós temos 3 pilares, né, apoiados por alguns estagiários. Uma delas teve um bebezinho, tá aí, Tamires. Um beijo aí para a Tamires, seu filhote. Matheus, dona Lúcia. E nós temos 2 estagiários. Eu lembro do nome de José, mas eu esqueço da Ilka. Então, essa disciplina, que se chama Tópicos Avançados em Sustentabilidade, já vou deixar aqui a minha propaganda para o ano que vem, acontece sempre no primeiro semestre de cada ano. Ele é um componente curricular de extensão e ele tem o objetivo de levar os alunos a protagonizarem ações de ensino, pesquisa e extensão relacionada à sustentabilidade. Então, veio a calhar que eu conheci David, ele entrou em contato comigo pelo LinkedIn. Veja só, o LinkedIn já está conectando mesmo pessoas, de verdade. Ele só mora aqui perto, quer tomar um café, eu digo, tá certo. Eu tenho meio aversão a café shop. Eu acho muito caro tudo, né? Mas meu marido sempre diz, você gasta 10 vezes mais dentro de casa do que lá, porque lá você toma um café, aqui você não vai dar só um café, né? Mas eu temo que não quero ir para... Acho que a criação de descendente de estrangeiro é assim, né? Mas restrito. Comer fora significava faz sanduíche como do lado de fora, era assim. Coitado do meu pai. Deve estar com raiva que eu estou falando isso. Bom, de qualquer forma, a gente teve essa oportunidade de conhecer David, e como a gente já tinha falado de vários outros mecanismos de eficiência energética. Os alunos, todos os alunos, como palestrantes de fora, o professor Cláudio também apresentou semana passada, trouxeram várias ideias, várias aplicações, normas brasileiras que incentivam essa redução de consumo de energia e novas metodologias que possam ser sustentáveis. Eu achei que essa proposta de David, que ele trabalha agora com com turbinas eólicas para a produção de energia. Ele projetou uma turbina eólica que ela, na realidade, em vez de ser com os blades na horizontal, são nos blades verticais. Achei super interessante a ideia dele. Você tem que vir falar para os nossos alunos para eles verem também que existe essa possibilidade. E aí ele está dizendo que estava procurando um aluno que soubesse mexer com CAD, talvez com Revit, porque ele vai querer fazer o projeto. Eu digo, conheço um que quer trabalhar com BIM. Nada melhor que praticar, né, na prática para sentir a dor, né? E aí a gente teve essa oportunidade. Então, daqui a pouco a gente vai estar introduzindo David Becks, mas aí quando você estiver pronto aí para apresentar David, me avise que eu vou apresentar ele, tá certo? Enquanto isso, eu vou falando um pouco da disciplina, tá bom? Como nessa disciplina a gente atua tanto em ensino, os alunos têm que dar sala de aula invertida aulas, né, e fazem todo esse processo de planejamento, execução e avaliação das atividades. Alguns alunos organizaram um concurso de vídeos, onde a gente teve 23 vídeos enviados, e os 10 melhores foram apresentados aqui no concurso. Nós tivemos esse fórum que é aberto e vai ser disponibilizado pelo YouTube para toda a sociedade. Tivemos podcasts, tudo que a gente ia aprendendo, a gente pediu que os alunos transformassem em podcast de 10 a 15 minutos para que a sociedade tivesse acesso ao que a gente está aprendendo aqui dentro de sala de aula. Então, a gente falou um pouco sobre a história da sustentabilidade, como é que aplica na construção civil, como é que a gente tem uso mais eficiente da energia. E aí, cada um desses assuntos e tópicos, os alunos vêm e apresentam. A minha área de expertise, que eu gosto mais, é a sustentabilidade social aplicada às construções, né? Que é a parte da qualidade de vida das pessoas, seja elas que constroem, que são afetadas nas vizinhanças, o planejamento ser feito através da escuta de todos os intervenientes. Então, são vários aspectos, a gente teve isso também. Então, hoje, vamos começar. Já está pronto? Posso introduzir ele?
3 minutinhos.
3 minutinhos, tá certo. E hoje a gente vai ter um palestrante que vai fazer a palestra em inglês. Não é a primeira vez que Luca fez, não foi? Da outra vez. O ano passado, a gente teve 5 palestrantes do Colorado State University, foi uma grande oportunidade. Alisson está sendo co-orientado por um professor de lá, e agora está bem aperreado com a qualificação dele, mas o orientador dele é gente finíssima. Todo mês a gente tem reunião 1 ou 2 vezes por mês com ele, e tem sido super rica a experiência, essa troca, e se Deus quiser vai estar lá também, poder continuar seus estudos. Muito bem. Enquanto a gente vai organizando a apresentação de David, eu vou falar só um pouquinho o que eu sei dele, mas eu vou pedir depois para ele apresentar ele mesmo para vocês. David trabalha há mais de 30 anos com gerenciamento de projetos de construção na elétrica e mecânica, tá certo? Ele mostra aqui que... Deixa eu ver o que mais. O background dele é Business and Administration, que é MBA, eles chamam de MBA, Master in Business Administration, mas nessa parte de administração. E eu vejo que assim, realmente ele tem um viés de criativo, né? Ele é bem criativo e fez um projeto. Esse projeto que ele apresentou é muito interessante, que ele vai falar hoje. E aí eu vou passar logo a palavra para ele. Eu não vou traduzir, vocês vão tentar entender. Aliás, quem fizer o podcast de hoje, quem vai querer fazer o podcast de hoje? Um podcast. Denilson, vai anotando tudinho, meu filho. Quem mais quer ajudar ele a fazer um podcast sobre a aula de hoje, essa apresentação de David? Não? Fazer um resumozinho e botar no podcast em português, que aí quem não conseguir entender em inglês vai poder entender o que você falar. Tá bom assim? Então, Denilson ficou responsável pelo podcast de David. So, David, my dear, I made a quick presentation, and I asked them to pay attention. You speak English slowly, and then at the end, if they have questions, I will come and help.
Okay.
Okay?
Excellent.
So,
excellent.
You have 30 minutes.
So, what type of students and people do we have? Architecture,
Civil
engineering, structural, electrical,
computer engineering,
civil, computer,
electrical engineering. He's a professor.
All right. What I'm about to present encompasses a lot of disciplines, not just wind turbines, okay? But I'm going to breeze through this like I'm going to go really fast, I hope. Otherwise, we'll be here all day. So, renewable energy, all right? It's huge. Whether you believe CO2 puts us in a crisis or CO2 is not a problem, doesn't matter. Renewable energy, we need it, okay? There's biomass, great for Amazon. Hydro, Brazil, probably huge in hydro. Tidal energy, geothermal. If you live in Iceland, it's great, right? Solar has its ups, has its downs. I'm going to focus on wind energy, all right? We all know about these guys, okay? Horizontal axis wind turbine. That's English, obviously. Horizontal axis wind turbine. In the vertical, there's 3 types. Savonius, these are scientists. Darius, and H. rotor. H. rotor, there's all kinds of types, okay? Application, where you see them, inland or on offshore or onshore, and then offshore out in the ocean. I inserted this today because just yesterday I saw this. Denmark, Germany, the Bank of Europe is giving a company $1.2 billion to do a new wind farm. So it's huge. If you're looking for a job in a couple years, think about wind because they're spending a fortune on wind. My particular patent and my vertical axis wind turbine competes with theirs. 72 of theirs at 15 megawatt gives you 1.8 gigawatt. Mine only 30 of these. So it's the adage, less is more is less. You don't have to build more or spend more to get more, all right? So let's just go quickly. I'm going to breeze through this. Major manufacturers, GE, you're looking for companies to work for, Vestas, Enercon, Siemens, Gamesa, and someday, I hope, Beck Engineering. All right, that's a wind turbine. When you see them, they look simple. They're not. They're very complex. These tons This is for a 3 megawatt wind turbine. So 10 or 12, 15, multiply that out. That's the amount of steel, concrete, iron, aluminum, and copper, okay? Again, this picture just tells you that there's a lot of material, okay? A lot of foundation. Now, it's interesting. This is rather deceiving. Foundation. Take a look at that little square, okay? Tower, wings, hub, nacelle. You see them offshore, all right? When you see them offshore, understand that you've got wind turbines spaced very far apart, okay? And all of the cabling goes back to a substation, electrical substation. Again, a 3-bladed wind turbine, horizontal, you have the horizontal axis, okay, comes into your gearbox and then your generator, very confined space. Innovation, they've gone now to direct drive generators, a different type of generator, eliminates the gearbox, but it puts all of the weight up front. There's no counterbalance back here. That's now gone, all right? Puts a lot of stress on this bearing. Understand that a wind turbine, okay, rotates this way, but it has to, the whole nacelle changes direction into the wind, okay? So this whole thing with these gears, this whole nacelle turns on the tower, okay? This gives you a perspective of size. They're enormous, very complex. They're enormous. This is the bearing, okay? When you see the blade, and they call them blades. When you see the blade, okay, all of these are 8-inch huge bolts. The blade is bolted to the hub, 3 of them, en deux, tres, okay? This motor, okay, turns the blade from the hub, and it changes the pitch, okay? So a wind turbine, the whole thing turns into the wind, and then the blades turn in pitch, okay? We follow? Very complex. That's the blade. There's your bolts. There's a person. You getting a picture? It's enormous. The industry is a $1 trillion industry. Remember that little square? I told you I saw that little square, and they called it foundation. No, this is the foundation. That's what you have to build to hold that tower up so it doesn't do this. You got a lot of wind. They didn't build enough concrete. Boom. And a tower, too much wind, and it starts doing this, and all of a sudden, it goes down. This is the base. There's your bolts, okay? There's the door that goes in. When you don't see that, when you see this from a distance, it's a beautiful thing. They look beautiful, right? They're tall and slender and 3 blades, and they spin, produce, a lot of electricity. But this is really what they look like up close. And when something in here goes bad, and they have to change it, they're trying to get that out that door, all right? This is the inside. Again, there's your equipment down below. Ladder goes all the way to the top, okay? These blades are made of fiberglass. Fiberglass flexes, it splits, it cracks, okay? It needs repaired. These guys have to go up and repair it, okay? Not exactly the easiest job. It's confined space. In the United States, OSHA has rules, very specific rules about confined space work. They violate every OSHA rule with regard to confined space, okay? When they go too fast, they overheat. When they overheat, it ignites lubricants. Lubricants catch on fire, and then this happens, right? So this is not uncommon. This happens, okay? Even when they're offshore, where it's cool, doesn't matter. They overheat, they catch on fire. Lightning, they're very susceptible. They've had a lot of engineering to try to resolve this problem. This is a molto grande problem for them, okay? When it happens, it has lightning strikes. It destroys the fiberglass blade. Offshore, so you have these, and each one's connected to the other. It's connected to a substation, connected to the onshore substation, transmission line powers your country. Okay. Again, they're spaced far apart. And not only are they spaced far apart, but they all have to come back to a substation. And then from that substation, back to the land. So how do they anchor them? Again, you saw the concrete, the massive concrete. When you put them in the ocean, you have to put this, and they take a ship, and they boom, 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 and they drive that into the whales, the dolphins, the mammals go deaf from the acoustic vibration, the sound, and they're showing up on shores dead. As this gets bigger, this gets bigger. As this gets bigger, this gets bigger and bigger, okay? Again, perspective. This is probably a 10 or 12 DESS megawatt. This is above the sea level, but this is what's below, okay? This is going out to shore. So they drop this down, they boom, 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 pow drive to anchor it, okay? And then they come in and they put the turbine on it, okay? This is the ship. They drive this down, and then they take the sections and they stack them and take the blades and they connect them, and that's the wind turbine. Now, I showed you how they have to go from one to another to another to another. This is the ship. This is the cable, and this cable goes out this and then out the back. And the ship travels and it lays the cable. And the cable, like I said, goes from up top all the way down to the bottom and out the bottom. And it's terminated, connected, spliced in the middle. This is the cable, and the cable, I kid you not, is this round. It's enormous, very, very heavy, and very expensive. Mucho expensive. When they have problems, and they do, they have to, they try to fly people in and help get people out. They have to stop PATA, the turning, so that the helicopter can land, okay? Very not safe, very dangerous, okay? And lastly, with horizontals, is they're finding out they're unprofitable. They're finding some of these are not profitable. Let's go on to vertical, all right? So back engineering, I've spent the last 4 years, anos, research, a lot of research. 35 years of electrical, mechanical experience in the Estados Unidos. I came here, and over COVID, I just spent a lot of time doing research, okay? We talked about the types, Darius, Savonius, H-frame. These are some wind turbines that are vertical that have been built and fail. They've all failed. And the reason that they fail is that as this turns like this, okay, the wind, if the wind is coming this way, the wind that pushes it, that's great. But as this comes around, guess what? It's coming into that wind. So the wind is wanting to push this back. So all of these designs are very, very inefficient because the wind that's pushing it is great, but as it comes around, it wants to come back the other way. So all of these, you have negative and positive, and negative, positive, negative, positive. So what I did is I came up with a solution. It's called innovation, okay? The innovation, what's different about mine? Again, offshore. What I did is I researched all the different types. And I said, no, that's no, sorta. I took a little bit of that. Yeah, sorta. No, definitely no. No, all right. These, I put sail wings up here. I used yacht racing. So if you're into yacht racing, you understand sails, right? I took sail technology here. I used it up here, okay? Blades, wings, okay? These wings, these blue, azul, light azul. What I did is, if I'm coming into the, if this is coming around into the wind, what do you want? You want this, okay? But when this comes around, okay, and gets to here, I want to change that angle. So what happens? Now I've got more on this side. So I've got more coming this way. And then when it gets to here, I want to change that angle. So when it comes around, no drag. So these wings change. All of these. 16, all right? These, same way, okay? Into the wind, I want to be this way. When I come around, I want to come around, I want to be this way. You understand? So these wings, the sails change an angle. This is the innovation that makes this turbine different, all right? These are all wings. They turn. Wings, horizontal, vertical, horizontal, vertical, horizontal. It creates a vortex, right? And these wings, same way. They change an angle, all right? What makes mine different is that there's a vertical axis goes all the way down, okay? It's supported with bearings at each level, all right? It supports that shaft structurally, all right? For you structural engineering guys, all right? It's supported, and that shaft goes down to 4 generators, all right? 3 today's gearboxes that change the RPM to drive the shafts. So I've got 4 10s, 40. The biggest horizontal, GE, Siemens, Vestas, maybe 12, 15 maybe, maxed out. That's as big as they can go, all right? I'm at 40, all right? So you follow? All right, so my building, all right, it's not a little teeny nacelle. Building's down at the bottom, and that building has the 4 generators, right? Helipad, all the switch gear, transformers, loading area, all right? Fully designed building, right? The wings, all right, these wings are airfoil. They're not fiberglass, just like an airplane wing. Very light, very strong. This part of the building is about a 40-story building. Okay. And each section is stackable. So you build the building, you have a crane, you stack it, you stack it, you stack it, you stack it. Okay. And then cable bracing that makes it so structurally, all right, it doesn't torque, doesn't twist. Now here's what I found in my research. In a place in Neshtafan, Iran, 1,000-year-old grain mills, all right, they figured it out. What I was telling you is that they built a wall, okay? So that when the wind comes over towards their grain mill, all right, their mill, all right, what happens is on one side, all right, you have a wall, all right? So this is coming around and not seeing any wind. But then when it comes around, no wall, lots of wind. Understand? So they solved the problem of what is called backtracking. Backtracking is this coming around where it wants to go back, okay? These guys 1,000 years ago, they solved that problem, okay? So what did I do? Well, I said, fine, I'm gonna put wings, okay? And I'm gonna build those wings all the way up my tower, okay? And then here, okay? So when the wind comes, all right, and this is entirely on a rail, okay? So again, this just shows how quickly you can build it, all right? Let's go back to offshore. Again, they're going marine cable. I decided, why do that? Mine are closer together so I can go overhead. I can do this, okay? Much less expensive, much cheaper. So again, theirs very expensive, mine much less expensive, okay? What does all this mean? All right. With innovation, with renewable energy, you have a lot of jobs, potential, a lot of jobs. If my turbine or someone else's turbine, all right, were being built here in Recife, the Atlantico shipyard, they'd be hiring you guys would all, and there'd be job offerings for everybody, okay? Now that's the big 40 megawatt. That's a big turbine, okay? So, well, what about on a small scale? Can you do small scale? And the answer is sure. I could do just 2 of these, all right, for a farm or for a business, okay? Or for a gas station, all right? If it's on a hill where there's a lot of wind, you've got 2 of these, 2 generators, all right? A little solar, you got EV charging, very versatile. So you got very small, Pequeno, and Grande. So you got a scale, all right, where these could be used. So again, let's compare them. There's the cell tower, goes to transformer, 10,000 customers. Mine, everything's down here, okay? All the blades, generators are here, not up here. Generators are here, powers 40,000 customers, all right? Look at the difference in the foundation, and this is where civil engineering, you have to understand, they've got a massive foundation. I've got caissons and bond beams. I've got much less concrete. They've got a lot of rebar, metal rebar. I've got a lot less. Remember the understanding. Less is more is less, okay? For the environment, all right, CO2, making rebar, steel, terrible for the environment. Very pollutant steel and concrete. So if you're using a lot less, better, okay? Much better. Again, here's your caissons, bond beams, different kind of total structurally, civil engineering, much different, okay? So you got, again, size. Here's comparison of size. Here's the New York City Eiffel Tower, okay? This is in feet. I apologize, not in meters. Eiffel Tower, my 40, their 10, and then it gets bigger and bigger, okay? Again, their foundation, the wind loads versus the wind loads and the foundation structure. Again, they have 3 blades, generator up top. I have 124, all dos cuatro, 124 wings and sail wings, okay? So a lot more wings. It's all about leverage, okay? If a carho goes off the road, okay? If you have a pole and you want to lift that car, okay? If you have a short stick, you need a lot of guys. Everyone here has a, okay? But if you have a long guy, you only need just 1 or 2 guys at the end, and that lifts that carho. You understand? That's called leverage, okay? So turning the generator is about leverage, all right? It's about the length of these wings, okay? Leverage equals torque. I've got 478 greater torque because I have more wings, okay? I have more swept area, what's called, all right? They have very small area, air parcel. I've got enormous. So you see the difference? It's all via just innovation, okay? That's it. So, any questions?
E aí eu vou fazer uma breve resumo aqui para quem não entendeu, mas eu achei muito inovador. Vocês, como engenheiros, podem perguntar e ver se realmente entende. O professor Cláudio aqui, que vai poder tirar as dúvidas aí da gente. Have you made any pilot?
Sim.
Sim.
But only small.
Mas pequenos.
Not very big.
Não muito grandes.
Made a model, okay, here in our casa, and I just use a fan. Okay, it was able to test the Coanda effect. And that was I needed to test that to see if that worked. And it did. Okay. I've not tested the upper wings. Okay, I'm hoping, to test that soon. This year, I'm trying to get funding, $2 million US for a 1/10 prototype, which would be 4 megawatt. Okay. If I can build that in the next year and prove that successful, all right, and have a university or an engineering firm, third-party engineering firm, certify that, and then I can get funding for an additional 5 to 6 million and build a 1/4, 1/4 scale. With 2 prototypes successful, then I become
Even Bill Gates
Bill
will.
Gates, Jeff Bezos, Zuckerberg. We'll all be having dinner together.
Yeah.
Don't
forget us. Don't forget us when you're.
We'll be chatting on my yard. Because the reason is, what country is going to buy a 10 megawatt when they can buy a 40? That is a lot less. It's a lot easier to service. Remember, their nacelle is at the top. Okay, so climbing up there and trying to work on and replacing a gearbox costs millions for them. And offshore, to bring a ship in to replace anything is enormously expensive.
For us that are worried about social sustainability, remember, the safety of the worker is very important. So a life is more than $1 million.
Yeah, it's.
If I lose one worker working at height, which is one of the biggest cause of death in construction, is working at height. So whatever you can do that you don't take your worker up there to do a difficult job, something that is happening over and over again, it's a very big deal in the social aspect, remember?
Yeah.
So, trazendo esse ponto também para as aulas da gente, acho que é importante. Vocês estão entendendo o que ele está dizendo? Alguém quer que eu traduza alguma coisa? Ele fez todas as diferenças dos blades assim, com os blades assim, e o dele que tem 120 blades. Em vez de 3 blades, ele tem 120, é menorzinho. A fundação gasta menos concreto, menos negócio, uma emissão menor e a produção bem maior, muito mais eficiente. 40 megawatts. 40 megawatts.
40.
Em contrapartida de 10, 12 megawatts. E aí ele vai fazer um prototipo 1/10, que vai produzir só 4 kilowatts, e se esse der certo, ele faz um de 1/4, tá? Que é 10 megawatts, e aí se esses dois forem bem, aí ele pode... Ele disse que só para fazer o de 1/10 custa $1 million, não é brinquedo não. Ok.
My 35 years of construction experience, when I started to design, obviously vertical, my generators are at the bottom. So I built a building that's an industrial, it's a large building, grande building. I have a helipad. So workers can come in, helicopter, land, get out and just walk right into the building. No climbing,
Isso é uma grande vantagem de ter o gerador na parte de baixo. Ele não precisa subir e trabalhar em altura. Toda a produção é feita embaixo. Então, isso é um grande ponto. Eu realmente...
If there's any repair work up top, because of my structure, my steel structure, I have 2 elevators. One breaks down, I got the other. So I have 2 elevators go all the way to the top. So they can do work safely.
Ele previu, né, e colocou 2 elevadores dentro do sistema, porque se um quebrar, ele tem um outro, e aí se eles precisarem trabalhar por uma casa em altura, apesar de toda a maioria das coisas estar na parte de baixo, dos blades serem tem uma vida mais útil, né, porque você viu que o material que ele usou para os blades dele foi o de avião, e não aquele de fibra que quebra o tempo todo. Tudo isso, né, é vantagem.
When they're offshore, they're out in the ocean, to do service work, that's lubrication, repairs, they have to go very large boat, grande boat, and they have to, the pull, and the boat's going like this, okay, and with the waves, right? Board into that little door, porto, okay, and climb up, okay? Mine, the idea is that I want to be able to have helicopter and men come in. There's a kitchen, there's a first aid room, in case there is an accident. All the material for storage, lubricants are already stored in the building. Everything they need, the tools, everything's in the structure, okay, in the building. Right? It makes everything so much simpler and safer for all the years that you're going to do service work.
Ele fala que ele planejou esse projeto. Eu sinto ele como uma construção mesmo, né? Como se fosse um building, uma edificação, onde ele tem parte de first aid, todos os equipamentos e instrumentos que ele vai precisar para fazer conserto, fica lá. Vai ter cozinha para os trabalhadores. Eles viriam de helicóptero e não com um navio grande, que teria que vir e portar tudinho. E, além disso, eles têm que subir, né? Não esqueça que eles vão ter que subir toda aquela altura. E o deles seria a maioria embaixo. E eles que, a longo prazo, isso aí vai criar muita economia e segurança no processo, né? De ter as turbinas embaixo, todos os equipamentos, tudo lá dentro, e você não precisa trazer um grande navio para trazer os materiais.
So, for you, students, career-wise, the renewable energy field is all-encompassing. There's the legal aspects, policy, civil engineering, marine biology, structural, mechanical, electrical, aeronautical. It's wide open. I mean, there's a lot of options, okay? Not just, it's a wind turbine, so it's electrical. No, it's much more than that. Right?
Ele diz que essa inovação cria emprego para todas as áreas. Ele diz que veja que isso aí ele trabalha com engenheiros elétricos, mecânicos, com os conceitos de aerodinâmica, esqueci metade. What else?
Marine biology.
Oceanografia.
Policy, legal.
A parte legal.
People that understand renewable energy and wind turbines that make policy.
Então, todas essas normas técnicas e a política e as leis que têm que ser criadas, né, para essa área, tudo isso ele abre um novo, essa parte de energia renovável, abre um caminho para muitas áreas. E tudo que as pessoas falam que as novas tecnologias vão tirar os empregos das pessoas, é o contrário que ele está falando, né? É um outro nível, obviamente que a gente vai ter que criar condições para que as pessoas tenham educação. Então, o engenheiro vai ter que saber Revit. Tudo bem. Então, a gente tem que mudar a estrutura de ensino para que os alunos tenham. O aluno é exposto a projetos cada vez mais com a sociedade, com as empresas, para que eles possam desenvolver essas habilidades, né? Alto. Speak loud.
Okay. Yes, the Vatican has wind turbine. In the night, you mentioned, like, taking the context of Brazil, for instance. Yes, Brazil mostly focus on renewable energy in terms of hydro energy, in terms of that aspect. So now looking at it in this aspect, wind is another form of electricity generation. So can you say that this your innovation is the best way we can conserve energy? We can somehow, because now we are looking about energy efficiency, how efficient are structures? Because taking for instance, like Brazil has renewable energy, for instance. So how can we create a more efficient structures, a more efficient way of preserving the one we have? Because based on the level, the global warming, wind is a form of something that you need to study the direction of wind to be able to fix the vertical height wind turbine. You need to know the direction of wind before you fix it. You can't just fix it in any position. So all those is another aspect. So putting it in the context of Brazil, based on the existing situation now in Brazil, based on the hydro aspect Brazil have, could you say that this is more efficient in terms of energy efficiency, or the one Brazil have, they should just go ahead with it?
Okay. Good question. All right. Brazil, if they're not number one, they're probably 2 or 3 in percent of renewable energy. The problem is not Brazil. we're not the problem, okay? China's the problem. United States, problem. Europe, the problem, okay? India, problem. Because Brazil has so much hydro. You have virtually no nuclear, almost none, okay? A lot of wind. Well, I say a lot, but you have a certain amount of wind, and you have solar, okay? And some biofuel. Right here. This part of Brazil produces 8% of the atmosphere's methane. CO2 is bad, but so is methane as a greenhouse gas, right? Sing, we agree? So biofuel is great we need more biofuel. They have no wind. They have like virtually no wind. But what you do have is enormous amounts of wind right here, down near Argentina. This is the equator, okay? And you have what's called equatorial winds. So here's Recife, here's Natal, here's Fortaleza, and here's Colombia, okay? So this area here, and in Rio, you have de Janeiro, DJ, okay? You have a little bit of wind here, right? But you have immense amount of wind here, an immense amount of wind here, okay? So there's two areas, okay? They're very, very, very good for wind. So Brazil is well poised in terms of area to add more electrical energy. And where does Brazil need more energy? Well, up here, right? It's the north. You got all your industry is down here, all right? So to get more industry up here, you need more power. And then to answer your question about power, there are countries, Malaysia, Africa, obviously you know, okay? Developing countries like Africa, you cannot bring in manufacturing unless you have a lot of power. Their economies, their GDP is down here because they have very little energy. They can't afford nuclear. Places in Africa, they don't have wind, biofuel is not an option. So the more places in Africa that you could put wind, it would help the people in terms of cost of energy, and it would help the GDP in terms of bringing business, incentivizing business. Understand? So places like Africa, you need more energy. It's no question. It's my motivation is not to get rich, but I'm too old. I'm 72 years old. I'm too old to worry about being Bill Gates. I invented this turbine because I knew there was a better way to make more energy, and more energy can be cheaper and can be provided more needed. Okay, so it was not so much about climate change, it was about solving the energy problem. We have an energy crisis. Places in India and in Africa don't have enough power, okay? So 40 megawatts, much better than 10, right? And by the way, at the same, their 10, $18 million. My 40, $18 million. So if you're a country like Brazil, you want to put more wind turbine up here, wind up here, or wind down here, better to spend 18 million on a 40 meg than 18 million on a 10 meg. Okay, so that was my motivation. Does that answer your question? Yeah. Anyone else?
So much. It was really interesting. I couldn't believe we'll have this talk and Oliver talk in crisis here. So thank you so much. And I think it comprehends several ingredients. Here we have 8 courses of ingredients. And I think it comprehends all of our students' issues of innovation. And we have been investing a lot in innovation. We have now which is the point of a great investment for innovation. Thanks so much. Bye. Then usually our extensions.
Eita, Duda.
One there.
By the way, University of Francisco has very good representation. Very good representation. I mean, outside of see, very good representation. And thank you. Thank you.
That is all. Thank you so much. I'm going to give you now 10 minutes. The next thing you know about, Luca vai falar today, the advantage of design. I'm going to talk to Joab so you can say my report. And I'm going to have a interview.
Já tá tudo. Oh!